Welcome back to probability, logic, and beyond. In this video, we're going to be learning about combinatorials and a common issue in counting theory called the stars and bars problem. Without further ado, let's get started. A permutation is a grouping such that the order of the grouping is important. In other words, S0 and S1 and S1 and S0 are considered unique groupings. A combination, on the other hand, is a grouping that does not respect the ordering of the items, so S0 and S1 and S1 and S0 are considered one and the same. Suppose we have 3 students. If we want to determine how many unique ways we can arrange these students into 2 chairs, we can use the permutation formula. This gives us the following groupings. The permutation formula treats groups in which the only difference between the groups is the ordering as distinct groups. If instead, we want to determine how many unique 2-person groups we can form from the group of 3 students, irrespective of the order, we have to modify the permutation formula to account for these duplicate groupings. In the example here, we can see that each group has 2 duplicate elements. If we add a factor of 2 to the denominator of the above equation, we can eliminate these duplicate values. This gives us the correct number of 2 student combinations we can choose from 3 unique students. Generally, we can express the number of ways to select k objects from a group of n using the following formula. We typically say n choose k to describe this formula, as we will use it quite often. Now suppose that we have 5 apples and 2 children. What is the total number of ways that we can distribute these 5 apples to these 2 children? For example, the first child could get 1 apple and the second child could get 4. Or the first could get 3 and the second could get 2. Or one child could get all 5 apples. This is called the stars and bars problem, and it often comes up in many tricky probability questions. To solve this problem, we can utilize the formula for distributing n identical items into R groups. In this case, n equals 5 and R equals 2, so we have 6 choose 1, or 6 factorial, over 5 factorial. To summarize the video, we learned the difference between permutations and combinations. Then, we learned how we can modify the formula for permutations to arrive at the formula for combinations. Finally, we learned how to extend the formula for combinations to distribute n identical items into R groups. Thank you for watching. Please subscribe to the channel for more content on probability, logic, and beyond.